Hello, bonjour, it's Laura here. In this video, I'm going to talk about a concept called limiting reactant. So in chemistry, we don't always have enough of each product or exactly the same amount of each product that we need in our equation, and that influences how much product is produced. So I'll give you an everyday example of a limiting reactant, and then we'll look at one in chemistry. So I've got a question here. How many peanut butter sandwiches could be made from 8 slices of bread and 1 full jar of peanut butter? So I've got the 8 pieces of bread here and the 1 full jar of peanut butter. Let's just say in 1 full jar of peanut butter that there's 30 tablespoons. So 30 tablespoons in that 1 full jar of peanut butter. So how much would we need of each of these to make 1 peanut butter sandwich? That's basically like our chemical equation telling us how many we need of each thing. So each sandwich should have 2 slices of bread and then 1 tablespoon of peanut butter. So we want to figure out how many peanut butter sandwiches we could make, and you can probably do this in your head. So think about that for a second, or pause the video and see if you can think about how many peanut butter sandwiches you could make altogether. All right, so if you think about it, if you've got 8 slices of bread and 1 jar of peanut butter, you could make 4 peanut butter sandwiches, because with each of these slices of bread here, we've got 8 of them. We need 2 for each sandwich, so we could make 4 altogether if we divide. So there's a sandwich, there's a sandwich, there's a sandwich. We divide that by 4. All we really need is 4 tablespoons, because we only need 1 tablespoon of peanut butter for each of these sandwiches. So that means we've got peanut butter left over. So with 4 slices, or 8 slices of bread, just 4 sandwiches could be made. And the way that you determine what your limiting reactant is your limiting reactant is the one that is used up. So the bread is all used up. All 4 slices of bread were used up, and then we have left over peanut butter. The reason that we call it the limiting reactant is the bread actually limits how many sandwiches we could make. So it's used up, the limiting reactant's used up, and it limits the amount of product that's produced. And our product here is our peanut butter sandwiches. All right, so remember we had a question a while ago that said we had a reaction with, I think it was oxygen in excess. In this one, really, the peanut butter is in excess. And then we've got limited amount of bread. All right, so that's limiting reactant in a nutshell. Let's look at another example with the same peanut butter sandwich model. So in this example, we're making peanut butter sandwiches. We've got 8 slices of bread still. So, but our peanut butter is different. Now we've got just 1 tablespoon of peanut butter. So how many sandwiches could you make with that? So if you've got 8 slices of bread and 1 tablespoon of peanut butter, you could only make 1 sandwich. Because here we're using up all of our peanut butter in just the 1 sandwich. So now our bread is in excess. We've got bread left over. So whenever you do a question like this, you should think about what's used up and what's left over. So in this one, is the peanut butter used up or left over? Well, the peanut butter is used up. And then, is the bread used up or left over? Well, we already discussed that. The bread is left over. So then how do we know which one is the limiting reactant? Well, remember the limiting reactant is going to be the one that's used up. So if it's used up, it's limiting, and that limits how many peanut butter sandwiches we can make. And then if it's left over, that's in excess. Right, so that's the concept of limiting reactant in a peanut butter sandwich model. So now let's take a look at it in an actual example in chemistry. So we've got a reaction here, and we've got a balanced equation. So it says we've got 2 moles of nitrous oxide reacting with 1 mole of oxygen gas, and then that produces 2 moles of nitrogen dioxide. So which reactant would be limiting here? So the best way to not the best way to figure out in our calculations, but the best way to conceptualize it is to look at what this would look like if we were looking at the molecules. So I've got a square here. This is the reactants, and we've got a legend. So the red balls are the oxygen gas. The red plus the blue, that's the nitrogen monoxide, and then the one that looks kind of like Mickey Mouse ears, the blue with the 2 red balls, that's the nitrogen dioxide. So that's the legend for our reactant. So you can picture each of these squares is the before and after of the reaction. So these are our reactants to start on the left. So to make one product, we need actually to split these oxygens, or and then we'll use one of the nitrogen monoxide. So let's look at making what it would take to make each one of these. So, because that's our product, the nitrogen dioxide. So that would go to, so this 1 nitrogen monoxide, and then we'll split this oxygen. So this red ball would go here as well. So this nitrogen monoxide could make this ball here, and then we'll take the other oxygen to make that. So then we've got 2 red balls and then 1 blue. So let's see, this one will go to here, and then 1 oxygen will go there as well. And then for this nitrogen dioxide, we'll use this nitrogen monoxide, and then we'll use the other one of those oxygens. So we've actually used up all of our nitrogen monoxide here. We've used up both of these oxygens, and we've used both of these oxygens. So we've got a leftover oxygen, and that is what this is as well, a leftover oxygen. So our oxygen is left over. We've got one of those. So remember the way that we define a limiting reactant, that would be the one that's all used up. So, and the one that's left over is in excess.